In this video, we're going to talk a little bit about getting started in Python programming, or in fact, getting started in programming in general. So one of the challenges that you face as a new student or a new programmer is that in the beginning stages of the language, you're learning the very specific tools, and the programs that you write tend to be pretty simple. Okay, so there's something that you can just do without thinking about it too much. It's something like print your name on the screen or the print the hello world that we've done before. Okay, so the challenge then is to be thinking about longer term how to solve bigger problems because the bigger problems are coming for sure. Okay, so one thing that we talk about in programming is the program development cycle, and that should be program, not programming. Lets me change that. So this program development cycle is 100% overkill when we're doing our first simplest programs, but pretty quickly it's going to be something that we're going to need to do. Okay, and it starts. I'm going to go ahead and use these flowchart symbols here. Okay, which we'll talk about more in a second. The first thing you have to do is design the program. Okay, so designing the program means first off that you have to understand what the program's doing. Okay. If you don't understand what the program's trying to do, there's no way that you can do it. Okay. You can't write a program. You can't automate something that you yourself can't do. Okay. So if I gave you something mathematically to take two numbers and determine their least common multiple. Okay. So the first question for you is, as a programmer, do you know what a least common multiple is? If not, you have to figure that out, right? Then the next step that you have to do is you have to figure out how to calculate that, right? By hand. Okay. So what are the steps involved? Okay. So you have to create an algorithm of some sort. Okay. Only then, when you have your game plan, so an algorithm is just a step-by-step way of doing things. Okay. So once you have your algorithm, then you can start writing the code. Okay. And I'm going to try to model that in class, that we're going to, especially as our programs get more complicated, we're going to think about. And I will often use comments to space out or to kind of put the sections of the code that we're going to need. Okay. So they give an example in our textbook about figuring out how to, I think they want to boil water or something like that. Okay. Yeah, how to boil water. Okay. So that's a good example of a problem that you don't really have to tell anyone how to boil water, they just do it. But when you're thinking about it from the computer standpoint, as I've said before, the computer is super literal and doesn't really know anything. You have to tell it everything. Okay. So a way that we could tell a computer how to boil water is to put water in a pot, put the pot on the stove, set the burner to high, and wait for large bubbles to appear. Okay. They also give an example of figuring out how to calculate salaries for a week for a salaried worker. Okay. So you'll have to ask how many hours are worked. You have to ask what the rate is, multiply those together, print out a result. Okay. So all of these things have to be done before you can start writing any code at all. Okay. And we have some tools at our disposal to help us with this. Okay. And the first is kind of what I said, but in writing. It's called pseudocode. Pseudo meaning fake or false, typically. Okay. So pseudocode would be something like this. Okay, make my box a little bigger. Okay, pseudocode is like step one. We're going to um, ask the user for two numbers. Okay. Two, we're going to, let's say, calculate the factors of each. Three, we're going to, compare whatever we're doing. We're going to go through and step by step. Okay. It often doesn't have numbers. That's just what happened to do there, but it could. Okay. But that's just a way in English to figure out what your program should do and get the steps. Okay. Something else you can do that used to be done a whole lot not done so much anymore, but it's still a good thing, and that's flow charting. Okay. And I'm in a program called Lucidchart that's available online. There's also an app. And I think it's free for educational users, and it's pretty interesting. Okay. So let's look at the basic shapes of a flow chart. Okay. And the first shape is this oval, which we call a terminator. Okay. And we'll have one for a start. Okay. And then we'll have another one for the end. Okay. So this kind of sets the parameter of our program. And you don't always know what the end is going to be at. Okay. We then have a couple of other kind of boxes that we typically use. We have one called a data box, which is a parallelogram. Okay. This data box is when we're asking someone for information or we're getting information from some source. Okay. So in this case, it could be something like input. I can find my home keys. Hours worked. Okay. And then we're going to connect these two with an arrow that shows the flow. That's why it's a flow chart. We start at start. First thing we do, we're going to input the hours worked. Okay. We then have another data box. Okay. Or an input output box, it's also called. We're going to input hourly rate. Okay. Again, we're going to have an arrow between these two. Okay. Next kind of box we're going to have is going to be a process box. Okay. A process box is where you do something, some calculation, some kind of thing. Okay. It moves out of the way a little bit. Okay, there. Okay. So in this process box, we're going to calculate the gross pay as hours times rate. Okay. Again, we need our arrow there. Move back up some more room there for the arrow. Okay. And then finally, we're going to have another input output box, which they're calling data box. Same idea. Okay. Where we're going to display the gross pay. And we're calling it gross pay because there would be other deductions, typically taxes, at least other things. Okay. For that, we'll put this guy over there. Not lined up exactly, but you get the idea. And that's our flow chart. Okay. So as our programs get more complicated, we may come back to the flow chart to help us explain what some of these things look like. Okay. So the next, all that's just in the planning. And again, the planning early on is zero. Okay, at least not much. But as we get more involved, it certainly is worth your time to go through a more rigorous planning process. Okay. So now let's look at the next step here after planning. Okay, and that's going to be writing the code. Okay, so it's not what I wanted. We get the right box. Here we go. The next step in the process is writing the code. Okay. In our case, that means we're going to get onto Google Drive, go to Google Colaboratory. We're going to actually type out the code that corresponds to our algorithm, to either our pseudocode or to our flowchart. Okay. That's going to be the next step. Okay. So we're going to go ahead and put a line here. Okay. After we've written the code, the next in the process is going to be to correct syntax errors. Okay. In the last video, I talked about errors, but let me talk about them again. So with errors, there are three types of errors. Okay. That's not what I want to do. Why won't you let me do what I want to do? Okay. So the first type of error is a syntax error. Okay. And that's a grammar error in the language. That's in my Hello World program. Instead of print in all small letters, I put a capital P. Okay. or maybe I opened a parentheses but then didn't close it, or maybe I started my hello world with a double quote but ended with a single quote. Okay, all of those are syntax errors. Those are caught immediately when you try to run the program. Okay, so correcting the syntax errors becomes our primary goal there. Okay, the next step, which is going to lead to our next issue in line here, okay, is going to be a runtime error. Not the next step, the next kind of error you can have. Okay, a runtime error. A runtime error occurs when you're running the program. Okay, these are often things like a division by zero is the most common error. Okay, your program runs just fine until you input a number that's a zero and try to divide by it. Okay, so the only way to find out these runtime errors is to test the program. Okay, that's our next step. Okay. And we'll talk more about testing as we go, but your testing should test for what we call boundary conditions. So if it's a number input, look for negative numbers, look for big numbers, little numbers, decimal numbers, whatever you think could cause trouble. Okay. So testing it will get rid of the runtime errors. Okay. And then the last type of error, it's going to be a logic error, also called a semantic error. Semantic having to do with the meaning of words. Okay. And with that, it really comes down to making sure that your program makes sense outside of itself. Okay. So again, if you're figuring out the LCM of two numbers, at least common multiple of two numbers, okay, don't just rely on your own pencil and paper work for that. Okay. You can go online and find LCM calculators. Type in numbers and make sure you're getting the correct answers. Okay. So that last part, then we're going to call that correct logic errors. Okay. And again, if this is a program that you're doing for someone else, then they will probably provide you with the correct correct data to work from. Okay. This is going to be hard to get, but this arrow basically needs to go back up to there. Oh, it does work. Okay. I like that. Okay. So that's the idea. Okay. And you go through this process. And you'll often go through the first time to give yourself the first version of the program, kind of a rough idea. Okay. And you may leave some things either rough. The printouts won't be very good. You may not allow input. You may, put in your own numbers directly to begin with, things like that. And that's kind of where we start. Okay. So as we go through the examples in class, we'll come back to this idea of going through these steps, okay, and looking for the different kinds of errors that we can have. Okay. More videos to come.